assessment asks us to give a carbonyl and an organolithium reagent that we could use to make the molecule shown. It says also that there are multiple possible answers, actually two. You're going to get both of them. In both cases, regardless of how we approach the problem, the last step is going to be an acid quench. So we can go ahead and work backwards to the acid quench step in terms of starting this problem. And so what we'll do is we'll assume that in each case, we're going through the following alkoxide. Now, stereochemistry is shown in this problem, but we're going to ignore stereochemistry for the purposes of what we're doing here. Once again, regardless of which way we do it, we're going through this alkoxide and then doing an acid quench at the end. Let's put our color-coded arrows back in here, our color-coded lines. That'll be the bond we make in method B. We'll make this one using method A. We put those lines there to basically show that we can take this group and make it part of our organolithium. And so maybe we use a cyclohexyl organolithium reagent. If we're going to add this, we're going to have a bond between this carbon, which is this one, and this carbon, which would be part of the carbonyl, in this case an aldehyde. One of the ways that we know it's going to be an aldehyde is because we're making a secondary alcohol. So this aldehyde plus this organolithium should make this molecule through forming the A bond. How can we confirm that? Well, let's number our carbons. We'll number that 1, 2, 3, 4, 5, 6. Number these 1, 2, 3, 4, 5, 6. We don't need to number the 2 methyls and that third methyl there. That shows us that that is the 6-carbon chain that is O-. And then the organolithium, let's number this as, I guess, 7, 8, 9, 10, 11, and 12. There's carbon 7, 8, 9, 10, 11, and 12. The only one that really matters here is that we've got nucleophilic carbon 7 attacking electrophilic carbon 1 to make the 7-1 bond. Now, if we take that same idea, we'll do this in orange to make the B bond. Here, we're going to make a bond between C2 and C1. So our organolithium that we might draw now would look like this. Again, we'll keep the carbons numbered to make sure. So this is carbon 2, where our nucleophile is. Number the rest of the chain, 3, 4, 5, and 6. So we're going to take nucleophilic carbon 2 and now attack electrophilic carbon 1 of our aldehyde. And so in this case, instead of making the 1,7 bond, as we did here, make the bond between 7 and 1, on the other side, we're going to make the bond between carbon 2 and carbon 1, this bond here. Both of these ways represent reactions where organolithiums could react with aldehydes, followed by an acid quench to give the product on the screen.